In this lesson, we'll talk about addition and subtraction of polynomials. Before we do that, let's learn some terminology for polynomials. We need to know what a term is. Term is a product of numbers, letters, or algebraic expressions, which are usually placed in a bracket. And here are some examples. Negative 2xy squared, one term. We have a product of negative 2x and y squared. 2/5 x and a bracket x minus 1. Again, that's one term because we have a product of a number, a letter, and an expression. Notice that if this expression wouldn't be in a bracket, then we wouldn't have one term. It will be actually two terms. Another example, pi x. A simple term, however the coefficient is denoted by a letter rather than a number, although this letter pi represents really a number. And following example, 5a to the negative 2 bracket a squared minus b squared. So yes, it's a single term because we multiply a number, a to the negative 2, which is certain expression, and another expression because it's in a bracket. So it's a product of three factors. And finally, 2 root x. Still, it's a product of 2 and an expression root x. So all of these are called terms. They are not necessarily all polynomials, though. To build an understanding of a polynomial, let's start with defining a monomial. A monomial is a term that is a product of a number, called numerical coefficient, and some letters raised to non-negative integers. So a term in one variable can be written in the form ax to the n, certain power of the variable times the coefficient a. In this notation, we assume that n is non-negative exponent. Could be 0 or any positive integer, however not negative integer. So with this definition, 2 root x is actually not a monomial, because the root of x is the same as x to the exponent 1/2, which is not even an integer. So that wouldn't be a monomial. Here we have some examples of a monomial. Negative 2xy squared, so the first example from the list of terms. It is a monomial because we have a coefficient and we have x to the exponent 1 and y to the exponent 2. This monomial is in two variables. Another monomial, pi times x. That's actually written in the form ax to the n, where n is 1 and a is pi. Negative 1, again a nice monomial. To write it in the form ax to the n, a would be negative 1 and n would be 0, because x to the 0 is 1, it disappears. Next monomial, 1/2 xyz. Perfectly fine monomial, however in three variables. We have three letters. And finally 5x to 16. Again a monomial where the coefficient a is 5 and the exponent n is 16. What's a binomial? Well, binomial is sum of two monomials. For example, we have these two terms, 2x squared and negative 3x. We can always consider this subtraction as addition of two terms, written like this, right? Because positive and negative really gives us a negative sign here. So try to keep this sign together with the following term. That means the sign of the term is in front of it, and we will always add our terms, even though if this plus is not written here. And another example of binomial. First term and a second term. What's a trinomial? I'm sure by now you see the pattern. We are adding three monomials. So for example, x squared, first term, negative x, second term, plus 1, third term. Or this polynomial, negative xyz, first term, plus 2x squared, second term, and negative y, third term. So it's time to define polynomial. Polynomial, as you may expect, is a sum of monomials. Any polynomial in one variable can be written in the form an x to the n plus an minus 1 x to the n minus 1, and so on, until we'll get a2x squared plus a1x plus a0. Since generally we don't know how many terms a polynomial may have, that's why this formula is written in a form that will cover any number of terms. So the highest exponent is n, and since we don't want to use all alphabet A, B, C, D, and so on, that's why we use A, but with subindexes 0, 1, 2, until the n, just to distinguish between the coefficients. And notice that this subindex for A corresponds to the exponent by the variable. So we know that an is the coefficient by the nth power of x. a2 is the coefficient by the second power of x, and so on. A couple more terminology words. Leading term. Leading term is the one with the highest exponent. Usually polynomial is written in decreasing order of exponents, so that's why the leading term is usually the first one. But if a polynomial is not arranged in decreasing order of exponents, we can still find the leading term by searching for the highest exponent. The term with x to the first degree is called linear term, and therefore a1 will be called linear coefficient. Finally, the term that doesn't have any variable, just a constant number a0, it's often called free term, sometimes referred to as constant term or zero-degree term. In similar manner, if we want to refer to the second-degree term, we can say quadratic term, but those are the most commonly referred to terms. That's why we learn those names. The next definition is about degree of a term or a monomial. Degree of any term is the sum of exponents of all the variables. So for example, if we want to find out degree of the term negative 2xy squared, since x is to the first degree and y is to the second degree, we're adding 1 plus 2, and that's why degree of this term is 3. The second example, we are adding exponents of all the variables. So this is invisible 1, x to the 1, y to the 3, z to the 2. We're adding 1 plus 3 plus 2. That becomes 6. So degree of this term, or this monomial, is 6. And what's degree of just negative 2? Well, we don't have any variable here. So this negative 2 is actually the same as a free term. No variable. So if we want to indicate a variable, we could write negative 2x to the 0, because the x must disappear. So x to the 0 is 1, it does disappear. Therefore, degree of a free term is really 0. That's why sometimes this term is called zero-degree term. So there's actually 3 names for this last term. If we know what's the degree of a term, the degree of a polynomial is defined as the greatest degree of all of its terms. So, to find out degree of this polynomial, let's write down the degrees of each term. For example, the degree of this term is 3, because it's 1 plus 1 plus 1. Degree of that term is 2, and degree of this term is 1. Therefore, the highest degree is 3. Therefore, the degree of the whole polynomial is 3. Okay, let's do the same here. The degree of 5xy is 2. The degree of 2x cubed y is 3 plus 1, so it's 4. And the degree of negative y cubed is 3. Therefore, the degree of the whole polynomial is the highest number, which in this case is 4. So I hope that's clear. Now let's look at this example of a polynomial. Which degree polynomial is that? Well, it's a second-degree polynomial because the highest exponent is 2. The numbers like 5, 2, and negative 7, those are called coefficients. The 5x squared, that's the leading term because it's of the highest degree. Therefore, 5 is the leading coefficient. And number negative 7 is the constant term or free term. X and y are the variables. So this is example of a polynomial in 2 variables. As I mentioned before, the leading coefficient is an, the one that stands just before the highest power of x. Polynomials are traditionally written in descending powers of the variable. For polynomials with more than one variable, the degrees of terms and alphabetical order of variables determine the order of terms. Let's see how it works on specific examples. If we want to write this polynomial in descending powers, we start with the highest degree term, which is negative x to the fourth. So we start with negative x to the fourth. Then the next term will be of third degree, this one. Therefore, we go with negative x cubed. And the following one is the second degree term, plus 2x squared. Then the first degree term, plus 3x. And finally, the free term, plus 1. So that's how we write a polynomial with one variable in descending order of exponents. In the second example, we have polynomial with two variables, p and q. So first of all, let's look at the degree of each term. This one is of degree 5. That one is of degree 1 and 2, so it's 3. And this one is also 3. And finally, the last term has degree 2. Okay, so it's pretty clear that we need to start with the highest degree, so it's degree 5. Therefore, we start with the term 2p squared q cubed. However, for the next choice, we have two terms with the same degree, so which one should be first? Well, we need to have some subrule. Since we have two variables, we are using alphabetical order. So since p is before q, we are looking at the degree of p first. Degree of p here is 1, but over there is 3. So this term will have to be written first before that one. Negative 3p cubed, and then negative p q squared. Finally, we copy the last term plus q squared, that's a second degree term. We also need to be able to detect like terms and distinguish them from unlike terms. Like terms are the terms with the same variables to the same exponents. So basically, if you look at, let's say, negative 2xy squared, this label xy squared, it's like tomato soup. This label has to be exactly the same in order for those terms to be like. So we see that this term and that term is like to the first one, because we still have xy squared everywhere. So all three of them are like terms. The coefficient doesn't matter, but the label xy squared must be exactly the same. Notice that those terms are not like to the 2x squared y, even though we have exactly the same variables, but the distribution of exponents is different. So, like I mentioned before, this could be considered as tomato soup. However, that may be mushroom soup. It's different type of soup, so we are not mixing them. Similarly, this term is unlike any of those three, even though we have the same degree. It's the third degree term, and here we had third degree terms, but we have only one variable. There is no y. And also the last term is unlike to any of those three, because again we don't have the same exponents. The y is to the first degree, not to the second. Like terms can be added. Sometimes we say combined by adding their coefficients. How does it work? Let's say if we have 2x plus 3x, we can think of it like of factoring the x out of the bracket. And then what's left to do is really adding the coefficients, 2 plus 3. So yes, it is 5x. Obviously, most often we are going to do it in our minds, but this is the theory behind it. As you notice, from here to there, we are really using distributive property of multiplication over addition, or factoring out the common factor. The other approach would be to think about adding apples, like 2 apples plus 3 apples is 5 apples, the same type of apples. Since subtraction is defined as addition of the opposite, we can see a minus b as a plus negative b. Then think of polynomials as sums of signed terms. So even though in this example you see a minus, we can think of it as a sum of 2x plus negative 3x. This kind of thinking will be helpful when we start simplifying polynomials. We can always think of the terms of the polynomial as written on separate pieces of paper, with the invisible plus between those pieces of paper. So if we wish to, we can always shuffle those pieces of paper in different order. For example, this sheet could go here and that one could go there. So whatever it will be convenient for us in the future. Okay, so let's start performing some operations and simplify whenever possible. If we have a negative in front of the bracket, that's like multiplying by -1. So when we multiply a bracket by anything, we're using distributive property. -1 times a is -a, -1 times -b is +b. Observe what's happened. We're actually changing the signs of the terms in the bracket into opposite. The invisible positive sign in front of a becomes negative, and the negative sign becomes positive. Okay, so in the next example, we're not going to write this invisible one anymore. I would encourage you to think in a way that in order to release a bracket with a negative sign in front of it, it's enough to switch all those signs inside the bracket into opposite. So to perform this minus, we are switching the signs inside the bracket. Therefore, we have 2x minus 3y plus 1, just like that. Okay, let's practice adding polynomials. Here we have two polynomials that are in brackets. However, those brackets are not really changing anything, so we can easily drop them. As long as we have positive sign in front of the bracket, we can release the bracket with no consequences. So what we really do, we add like terms. The like terms here are the quadratic ones, 2x squared and -4x squared. Well, let's add them. 2 minus 4 is -2 of what? Of x squared. And then the linear ones, -3x and +x. So we have -2x. And finally, the free terms, +6 and -3. So that's +3. And the addition is done. Notice that each type of like terms I underline differently, so it's easy to follow and avoid possible mistakes. I suggest you do this as well, especially if you deal with very long polynomials. Also, the other hint is, as soon as you underline like terms, combine them and record the answer before you start underlining the other type of terms. This will help you in collecting all terms correctly. Okay, what do we have here? We have exactly the same polynomials, but we need to subtract them. So because of this minus and a bracket here, I would suggest that we rewrite entire question with no brackets at all. So we can release this bracket with no changes. We have 2x squared minus 3x plus 6, and then we need to distribute this minus by switching signs inside the bracket. So instead of -4x squared, we have +4x squared. Then it's minus x and +3. This is really essential. Write everything patiently with no brackets and then collect like terms. Otherwise, it's easy to get confused and make some errors. Okay, so now it's time to collect like terms. 2x squared plus 4x squared is 6x squared. Then it's -3x and -x. We have -4x. And finally 6 plus 3 is +9. Final answer. The next example is already a little bit bigger, so it's very important that we do one step at a time. For example, release the most inner bracket first and copy everything as it is. So copy patiently, don't try to skip those steps. So let's copy these two terms as they are. We are going to release this inner bracket first. So because of this minus, let's put a red alert here, we need to reverse all the signs inside the bracket. So the +3y squared becomes -3y squared, and -4y, it's +4y. Plus, since we have a positive sign, this square bracket is not really essential, so we can drop it at once. And inside, we can release this bracket as well. because it's the most inner one. So let's keep the round bracket still, 7y cubed, and then switch signs inside this inner square bracket. So it's negative y plus 2y cubed. Complete the round bracket and copy the rest. Equals. The next hint that I have for you is clean up everything what's in a big bracket first before releasing it. Why? Because the expression becomes easier and it's less likely to make an error. So copy the minus, copy the bracket patiently, and collect like terms within this bracket. 5y squared minus 3y squared is 2y squared, and then 2y plus 4y is 6y plus 6y, square bracket. Now here we have round bracket, but we have a plus before it, so we can release it with no change. In the meantime, we can add the 7y cubed plus 2y cubed. That will be plus 9y cubed. Copy the negative y and copy the 3y squared. Okay, one more step. We can release this square bracket by switching signs, so we have negative 2y squared, negative 6y, and copy the rest. Plus 9y cubed minus y and plus 3y squared. Last step would be to collect like terms, starting with the highest degree term. So we'll get 9y cubed. Now we can collect the square terms. 3y squared minus 2y squared is plus 1y squared. Obviously we don't need to write this one, so it's just y squared. And negative 6y, negative 1y is negative 7y. Final answer. And last example, we need to subtract this polynomial from that polynomial. Remember, subtract from phrase goes backwards. So we need to start with this polynomial in order to subtract something from it. Okay, let's rewrite it. X to the 3a plus 3x to the a minus 2, and then we subtract the whole polynomial. So we need to place a bracket around this polynomial. So it's minus in a bracket x to the 2a minus 3x to the a and plus 1. Okay, now when we have our expression already written down, the rest would be to release this bracket and then collect like terms. So that's what we get. Minus x to a plus 3xa and minus 1. Okay, let's collect like terms. The highest exponent is obviously 3a, even though we don't know what a is, but definitely 3a is larger than 2a. We assume that a is positive though. So x to the 3a, that's the first term. Then we have negative x to the 2a, negative x to the 2a. And finally 3x to the a plus another 3x to the a. So we have altogether 6x to the a. Three terms, negative 2, negative 1, gives us negative 3 as a final answer.